Okay, let's get started. So in this talk, we try to understand JVM and JVM settings in Cassandra and how garbage collection works in Cassandra. And we'll also have a closer look into the heap memory. Then we try to understand few garbage collectors and how they work. And the main focus is how CMS GC collector works in Cassandra because as of now, with Cassandra, you get to see this is the default garbage collector. So the focus is more on this particular topic. How CMS garbage collector works and what are all settings related to CMS garbage collector, right? Then we also see some of the common GC errors in Cassandra, and we'll try to see some good practices to reduce the GC pause and GC errors. And we'll end the session with some final thoughts on the overall topic. So let's start. So, little bit about me. My full name is Anil Mithana. I'm a certified Cassandra admin and certified Cassandra developer. I work as a DBA, and you can find me on the LinkedIn link provided. Now, who this talk is for? So, the idea is to have, I believe you must have some kind of a background knowledge on Cassandra. So, that would really help you to understand this topic. So ideally, if you are a Cassandra DBA or you're RDBMS DBA who is practicing Cassandra, or you can be a beginner who is learning Cassandra, can get most out of this topic. Now let's start with JVM. So what is JVM, right? And how come? What is the relation between your Cassandra database and JVM, right? Why I should understand JVM? Now it is very important because Cassandra is written in Java. Okay, Cassandra is a database basically developed in Java. Now, when you want to install Cassandra on any Linux server, okay, let's say some operating system. Here I have chosen Linux. Now, when I want to install Cassandra on top of your Linux server, you cannot do it directly, right? See, with the Java you can develop a program, but you Java doesn't have capability to run that program directly. So you need something called JVM on top of your Linux machine. Okay, so this is how it looks like. So that is the very first reason when you want to install Cassandra, and when you start looking into the prerequisites, it asks you to install latest version of Cassandra, right? So either it can be Oracle Java Standard Edition 8 or it can be OpenJDK 8. Okay, so the idea is to install. You must do latest version of Java as part of your Cassandra installation itself. Okay. Now you can notice experimental support of Java 11 was added in Cassandra forward. But that is still experimental mode only. As of now, until unless specified, Oracle JDK 8 you should use it. Now, now you got to know you need to have Java installed and JVM up and running. Then you are good to run Cassandra on top of it. Now, Cassandra allows you to uh, you know uh, keep various options on how you want to start up your JVM. So that you can do it by setting up a file called jvm.options file. Okay, so all your heap settings or garbage collection settings, all that stuff will be configured in this particular file. So previously, like before Cassandra 3.0, all that those settings are available inside Cassandra env.sh, but from Cassandra 3.0 release, all those things are like maintaining. So Cassandra is maintaining all that Java garbage collection related settings or heap settings inside a file called jvm.options. Okay, so basically your jvm.options file will be sourced by Cassandra env.sh file itself. Okay, so let's see what we have inside jvm.options file to understand little more about how you can start up a JVM. Now, if you notice, there are so many default values and default formulas to set up your heap settings or garbage collection settings, but we'll have a closer look on them now. So I'm talking about all the time like a heap setting, correct? So this is the area where you can configure your heap. Now, if you didn't specify anything, Cassandra will use this formula, and it configures your heap for your JVM from your OS memory. Okay, so what it means? So now, by default, okay, if your machine is having less than 1 GB RAM, and you are going with the default settings from your jvm.options file, so the heap will set to 50% of your RAM. If your memory is more than 4 GB, the heap size is set to 25% of the RAM with the cap of 8 GB. So that is very important. Now, what it means? Simple. Let's say you have a RAM of 2 GB. So, put all those values inside this formula. You will get this piece. And ultimately, the value is 1 GB. Okay. So, now this is, pay attention here. If you have a 40 GB RAM available on your OS, and when it goes to this formula, you get 8 GB, right? So 8 GB, even though you have 40 GB RAM, it the maximum you can have it is 8 GB only, right? Even though you have 100 GB RAM, when it goes to that default formula, it sets the heap size to 8 GB, because 8 GB is the most safe point for your heap from very long time over the years. So the idea is like, you, because the default garbage collector for your Cassandra is CMS, and when you use CMS, the ideal heap size should be below 14 GB. So 8 GB works very well. So that is the reason it is like, putting that cap of 8 GB, right? So we'll try to understand more about that piece. But for now, if you don't want to use this formula, then there are two options, right? These two flags you are seeing. You can use these two options to set the heap to your own value. Okay, so let's try to understand these two options. Those are like XMS and XMX. Why there are two values? So let's see like this. Let's say you set your XMS to 4 GB and XMX to 8 GB. What it means is, I try to think S as a startup value. So XMS S, thinking that way, startup value. So you're telling, when you start your JVM, start with 4 GB as a heap size, and I know think X as like a maximum, meaning it can resize to 8 GB, right? Whenever you need more heap, it can go and grab memory from your OS, and it can resize till 8 GB. Now, the good practice is to have same value for both these options, meaning, because the heap itself goes through a lot of pressure during the garbage collection, right? And you don't want to put additional burden for resizing heap itself, correct? So you want to use 8 GB as a heap memory. So let's get take that value and keep it for XMS and XMX. That's why you can lock that particular memory into heap from your OS level, right? You don't need to swap out between OS and heap, right? So that's a good practice. Like keep it same number. Now, at this moment, I think it's a good time to have a high level view on how heap looks like, right? Now, your heap basically divided into two generations, younger generation and older generation. So this is interesting, right? See, now your younger generation again divided into mainly two areas, Eden and survivor space. And there are like two survivor blocks, isn't it? Now, why is it? What are all these terms, right? Eden space, survivor one, survivor two, younger generation, older generation. We really have a very deep look into all of them as we go through further. But at this moment, this is how your heap looks like. Now, garbage collection, right? All the time we are talking about, right? garbage collection, but let's understand what is it. So, so first of all, let's say you developed a program called X using some programming language. It can be C, C, P, P, or Java, anything. Okay. Now, when this X is running, it creates objects in the memory to support those operations, whatever happening at program in the program. Okay. Now let's compare it to Cassandra. Now, Cassandra is an application, or it is a program. It's a database software, right? Which is developed in Java. Now, when Cassandra is up and running, it creates objects inside the heap to support some kind of operations happening inside the Cassandra database. Okay. Now, one good thing about Java is most of your most of the time, you don't really need to bother about how to deal with those objects inside your heap. Okay, so Cassandra will create sorts of objects inside the heap when it is up and running, because uh, you have a JVM. What JVM does is it keeps a track of unused objects or dead objects inside the heap, and slowly it will clean them up automatically. You really don't need to worry about your memory management with your allocated objects inside your heap. So that's what automatic memory management, which is there from very beginning of Java. So the fancy name to automatic memory management is garbage collection. Now, okay, when you go with the name, right, garbage collection, we tend to think like, garbage collection is finding and throwing away garbage. That's what normally comes into our mind when we think about garbage collection. But you think in a opposite way. Now, that is what I mean by garbage collection is finding the used objects, live objects in the heap. Once you find them, then mark the rest of the objects as dead objects and clean them up. Okay, so finding the live objects and then marking the dead objects and cleaning the whatever the marked dead objects, right? That's what garbage collection is. Okay, now some few important points related to these objects. Okay, now what are they? Very important to keep them in your mind. The majority of Cassandra objects which gets created inside the heap are short living, very short living. They don't live for a very longer time. Okay, so there might be some objects which might have a references to the new objects, but they will be in a very small number. Okay, so meaning some few objects can live for some time. If an object survived for some time, that expected to live for a very longer time, but that objects also will be in a very small number. Okay, now you can look into the graph. You can see the number of objects and the object age. They are like very quick. They will become unused. Okay, now garbage collection is something finding whatever the live objects and then marking the other objects as dead and clean them up. Okay, right. Now all the time we are talking about objects are getting created when Cassandra is up and running, but what exactly is it, right? Now, compactions. Cassandra, if you are doing compactions at Cassandra level, that generates lots of short living objects inside your heap. Mutations, meaning like write operations and read operations will create objects in the heap. Let's say you're deleting lots of data and you're creating lots of tombstones inside your Cassandra database. Every time you read those data, tombstones will appear into your memory, and that will put additional burden on the heap, and there will be objects will be created. If you have wide partitions and you're reading them, that is also a place where you will see garbage collection issues or pressure on the heap. So now you got to know uh, Cassandra. When Cassandra operations are going on, it creates objects into the heap, right? Now, So JVM uses the concept of mark and sweep. That's what we understood when we talk about garbage collection. So what it does is whenever it starts doing garbage collection, it has to start somewhere, right, to find out who is live. That is what GC route. So it starts from the GC routes, and it try to see what are the live objects directly or indirectly connected to the GC routes. Once it identifies them, then once it is done, that particular piece, then it marks the rest of the objects as a garbage, and it just sweeps them out, right? Now point here is we still need to understand what it does with the live objects. So it is finding the live objects. We didn't talk about what it does with them, right? Correct. Now we'll come to that point. So I think this is the moment uh, to understand a few more things on garbage algorithms. Now your JVM, most of your JVMs, okay, most of your JVMs uses two garbage collection algorithms. So it is not a single algorithm which it uses to do the garbage collection. No, two. Most of your JVMs. Now, when it when you think about Cassandra, Cassandra uses the two garbage collection algorithms that you can see it from here, from these three parameters. So it is using pair new GC collector and CMS concurrent mark and sweep garbage collector to do the garbage collection on your heap. Okay, that's how it works. There will be two algorithms. Now from the picture, Cassandra uses these two combinations to do the garbage collection on the heap. Now, more specifically, a pair new GC collector will work on younger generation. CMS garbage collector will work on old generation. Okay. Now, so this is the time. This is we discussed already. Younger generation area parallel new GC collector, and on the older generation, your CMS will do the garbage collection. Now there are like nearly like 12 garbage collectors are there in the market. Now these are the two garbage collectors, combination we are using for Cassandra. Let's try to understand few garbage collectors and how they work. Now the very first one is like a serial collector. It is available from very first version of the Java. What it does, see, you think about this green threads as Cassandra application threads, okay, like Cassandra database threads. Now what it does is whenever it has to do garbage collection, whenever that object gets filled in your heap, what it does is it stops the entire application threads, and with one single GC thread it does the garbage collection, like uh, finding the live objects and marking the dead objects and sweeping them out. All that stuff happens during this particular period, okay, with one single GC thread. So once the garbage collection is done, it starts all the application threads. So during this particular time, you get to see stop the world pause errors in your GC logs. Okay. Now there is something called parallel collector. Parallel collector is similar to serial collector. The idea is here is multiple GC threads does the garbage collection. So the pause time would be little less compared to your serial collector. Okay. Now comes your CMS, which is the default one for your Cassandra. Now CMS works in more accurate way. What it does is it whenever it has to do the garbage collection, it stops the application threads and it does the marking of the live objects. Once the marking is done, it starts the application threads and again it do the marking of the live objects whichever got created during this particular period, right, from this piece to here, right. So that marking will happen along with the application threads. So the point here you need to notice is garbage collection is portion of the garbage collection is happening along with the application threads itself, right. So once it marks the newly created live objects, it again stops the application threads and it just remarks everything, meaning it is just evaluate, like evaluate everything. Whatever it has information it is gathered, it just thinks everything is correct or not. So once it is done, once the remark phase is done, normally remark phase is takes little more time compared to marking. Now once it is done, it starts the application thread, and the sweeping part will be done along with the application threads when application threads are appended. Okay, very important. Now CMS is will take like more CPU resources because to do the garbage collection, because most of the thing is it is happening during the when application sets are up and running. In general, like CMS will uses lots of CPU resources, okay, to do garbage collection. But the thing is, you get to have a very less GC pause time when you use CMS. Now, now by this time we understood what is garbage collection, like in a very definition way, and we got to know what is JVM is doing, what are the heap, and what are the various blocks inside the heap. Okay, and there are like what are the garbage collectors and what they do, how they work. Now let's go a little bit deeper and try to see how garbage collection works inside the heap. Now let's assume this way: we are living in a very perfect world, meaning your Eden and the Survivor 2, all these areas configured in a very nice way, meaning like in a very proper way. You did, you understood how your Cassandra database having the same set of actions on a daily basis, so you know how your Cassandra database behaves, right? Accordingly, you have tuned your CMS settings, which are shown here, and it was so perfect. There are not much changes are happening, like you are not dynamically changing your Cassandra work, right? So everything is so good. Your heap is properly tuned, and let's say at Cassandra level also, you're not deleting much, so you are not having much tombstones in the database, and your data model is so perfect, so you have partitions with less than 100 MB, and you have a very proper compassion strategy in place, and it is doing very good job, so everything is so good. Under such circumstances, let's understand how heap works. Okay, now, so whenever Cassandra is operating, whenever Cassandra is up and running, it starts creating objects inside the Eden. Okay, all the time we are talking about objects are getting created in heap. The area is Eden. Eden is the place where new objects will get created. Okay, so this is the only area where objects will get created. Remember that point. Now once the Eden area is filled, this is when your JVM will instruct minor GC. Okay, so once your Eden is filled, it JVM will do minor GC on top of your younger generation area. Okay, who does this? Parallel new GC collector. Okay, so what happens here? As we discussed, it marks the live objects. So it just goes and marks what are all live objects. Okay, imagine this are live objects. Now it will move them, all those live objects, into your survivor space. So one point here is at any given time only one survivor will be active. Now once it once it copies the live objects into the survivor, the process you call it as a promotion. So if an object is copied from one region to another region, you call it as a promotion. And remember, promotions are very costly. Promotions are very costly. Okay, please remember that point. Now once it moves, it marks them as like it keep a count on that object, like 1 1 1, meaning this object is survived one minor GC cycle. Okay, so once it moves, it cleans the entire area. It just sweeps out, and it cleans everything from your Eden. Now you might be getting a doubt: why it has to copy and then clean? Why cannot it just go and clean those dead objects? If it does in that way, you will end up with fragmented memory, right? Patches of your memory will be having lots of patches, isn't it? So that's why it will move everything from first to the survivor, then it just cleans everything and defragment your hidden area. So after one minor GC, this is how. Okay, so after first minor GC, this is how your heap looks like. So your survivor having a live objects which survived one garbage collection. Okay, now your Cassandra is still up and running, so it still creates objects. So Eden is getting filled with the new objects. New objects are coming in, and your Eden space again filled up. Okay. Now what it does is again JVM instruct minor GC on your younger generation area. Now again it marks the what are all live objects. So this is one, it marks what are all live objects. Let's see, this is the live object, still this is live objects. Imagine this dead. Okay. Now what it does is it again copies all these live objects into survivor 2. So that is the reason you have two survivors. Correct. Now once it moves everything into the survivor 2 and it marks them, it is keeping that number, right? How long, how many times object survived. So once it moves and have that number, then it cleans the Eden and survivor 1. So after second GC, this is how your heap look like. So you will have objects which are live. Maybe it survived two times, one time, right? Now this is how it happens. Objects are getting created in the Eden. Once Eden is filled up, it moves all the live objects from your Eden space and survivor 2 to survivor 1 again, and it marks the, if any object survives from survivor 2 to survivor 1, that will be marked as a 3, right? So that's how it happens. And let's see the picture of your heap after 5 minor GCs. Let's say this is how it is looking now. So in your survivor 1, you have objects like, imagine this object survived for 5 garbage cycles, and this one is survivor for 2, this one is survivor 1, this is survived for 3 times. Okay. Now if you see this object, every time there is a garbage collection, this is getting promoted, right, in between survivor 1 and survivor 2, isn't it? That object is getting promoted between survivor 1 and survivor 2 repeatedly. And remember the point, if 2 points, basically promotion is costly and you're doing that promotion, all right? So one thing, meaning you're doing a costly operation. And second point, when we talk about garbage collection, we said if an object is survived for some time, it tends to live for a very longer time, right? Now by considering these two, and you need to set up a threshold, like saying if an object survives for 5 GCs, 5 minor GCs, so you need to keep that threshold value. I'll show you that threshold value where we need to keep it up. So once it touches that threshold value, then it becomes a matured object. So you call it as an old object or matured one, meaning it is matured enough to get promoted into old generation, so that it can stay there, right? It can, you can avoid costly promotions. So because it is survived, it tend to live for a very longer time. Then there is no meaning you keep on promoting between survivor 1 and survivor 2. So you can mark it as a mature object with the setting I'll show you shortly, and it can go and sit in the old generation. Now you is it making sense, like why the naming is like old generation, right? Now that setup, you will do it by this option. Okay. Here it is set to 1. The default value is set to 1, meaning what it means is if an object survives for one minor GC, you are promoting it basically, right? but that is bad. uh, why it is bad, we'll try to understand, but at least that the good practice is keep it like a 4 or 5 6, right? So you let the object die inside the younger generation itself, so that you can avoid the costly promotion, isn't it? We'll come to that point. But this is the setting to define that threshold, to define that maturity for that object to get promoted into the old generation. Okay. Now, so here you can see now objects will start coming into your old generation, isn't it? So all, whenever that certain conditions meets, object will finally comes and sit here. Now there will be a Java thread which will monitor your space inside your old generation. The moment it fills up 75%, it initiates a major GC, and that major GC, who will do that? CMS. Now CMS comes into the picture now, and it looks the live objects. Again, the concept is same. So it looks what are all the live objects inside this 75% area, and once it identifies them, it and it once it identifies the dead objects, it cleans the dead objects, and it will rearrange the live objects. Okay. One bad thing with the CMS is CMS will not do defragmentation. So you will end up with the patches inside your old generation area. So major GC is not that bad, but obviously whenever CMS doing major GC, it occupies lots of CPU resources, and there is no memory fragmentation after cleaning it up, right? And if you happen to be in a situation where your system is doing a minor GC and major GC concurrently, that is also a bad scenario, right? So if you think in that way, major GC is little bad, right? Now, so those are things you should keep in mind to understand, further. So as long as it is doing in this way, like objects are like, once object become mature, it is getting promoted into your older generation, and CMS is doing the garbage collection for you, because CMS is like within the time, like it is doing the garbage collection, right? It is starting at when the object is like older generation area 75% is filled, it is start doing the garbage collection, it is able to fill it, clean, do the job. You got it. uh, it is able to finish its job also, because you are doing garbage collection, you're starting it at 75% itself, right? When it fills up 75%, you have enough ample time to clean it up. Everything is good, everything is good, so perfect, we are living in a very perfect world, right? That is be like, that is defined here, when to start. That's the reason you have these two settings. If you want the CMS to kick in more quickly, you need to tune this particular parameter. Okay. Now excuse me, but we don't live in a perfect world, isn't it? So you went with the default values. Let's say you didn't tune your this areas, these regions. Okay, you didn't define them, you didn't put the right size to your hidden space or survivor ones or old generation. You didn't pay attention to your heap settings, and you didn't pay attention to your CMS settings. You just went with the default values, and you are doing lots of deletes at the Cassandra level, meaning you are generating lots of tombstones, and your partitions, you have lots of wide partitions inside the database. And imagine you're in a read heavy workload, and you are using sized here, or you're in a write heavy workload, and you happen to be using a leveled comparison strategy, like, so things are a little messy. in the database and even at the heap level. Now we'll try to understand what happens. Now, if you went with the default values, let's look into the heap settings, how much I get. So let's say you got 8 GB RAM. You have, okay, let's say you have 40 GB RAM, so you got 8 GB heap. Okay, now you have 8 GB heap. How much I get for my younger generation? How much I get for older generation? That is the question, right? And how much I get it for Eden and Survivor 1 and Survivor 2, where I can tune these parameters. Now, you do that by setting up a parameter XMN, young generation, new generation. Okay, think in that way. Now, this is by setting this value, you can set up how much you want to have it for younger generation. Whatever left is will be allocated to your old generation. Okay. Now, by default, it uses this formula to calculate your younger generation area. So if you go with the default value, you will end up with the 1/4 of your heap size or 100 into number of cores. Okay. Now 100 MB into number of cores. Okay. Now let's see, you have a 8 GB heap and you went with the default value for XMN. I mean, you didn't set up the XMN value. You went with the default value for your younger generation. How much you got? 1/4 of your heap will get allocated to your younger generation, which is 2 GB. So from the picture, 8 GB is your overall heap memory, and you went with the default value. You got 2 GB for your younger generation, 6 GB for your old generation. Now, how much I'll get for Eden? How much I get it for Survivor 1 and Survivor 2, where I can define them. And the rule is there is no direct assignment for your Eden. So you cannot define Eden value directly. You can give, you can tune your survivors, and whatever is left is will become, that will be available for your Eden. Okay. Now, what is that? Let's see. Now you have 2 GB for your younger generation, and this parameter, these options will define your Eden space. Here it is set to 8% ratio, right? 1:8. So the survivor ratio is equal to 8, meaning it is a ratio to your Eden space. So 1:8. Now what it means? So your younger generation area will be divided into 8 pieces because the ratio is 8, and one piece will be allocated to your survivors out of that 8 pieces. Okay, so meaning you have a 1048 MB and will be divided into 8 pieces, so that each survivor will get the one piece, and the rest will be allocated to your Eden space. Okay, now let's put that here. So you have 1.5 GB here, 6 GB here, and 256 MB, 256 MB here. So these are the default settings, and we are going with the default settings. Okay, and here you okay. Now objects are getting created, and you are doing like lots of compactions. Compaction is happening very frequently, and you have tombstones, you have white partitions, and you are doing write operations and read operations. So your object allocation rate is high. So your lots of objects are getting created inside your Eden. So your Eden is having only 1.5 GB. So that because of that, and your allocation rate, object allocation rate is very high. So your Eden space will get filled very quickly. Okay. So once your Eden space is filled up, your GC will come into the picture, right? And let's say, imagine 1 GB objects are died, and still it has to promote 500 MB objects, right, to survivor 1. But your survivor is not having enough space, isn't it? You have only 256 MB, but you have to promote lots of objects. Now here what happens is, because you didn't define your survivor properly, those objects will directly gets promoted to your old generation. Now you call it as a premature promotion, right? See, what we thought is like what we uh, understood is whenever objects meet some maturity, it has to go into the old generation. But but your eden is not defined properly. Your eden is having very less space. Your server is also having very less space. So you are tend to see premature promotions into your old generation. Okay. And so in your case, your old generation area also filling up so quickly because of the premature promotions, right? So imagine when it is 75% is filled. So thread is watching, right? Now it will ask CMS to, hey, CMS 75% is filled. Now you start doing garbage collection. So CMS comes into the picture to do the garbage collection, but your allocation rate is so high. And if you fall into a situation, if the CMS falls into a situation where it wants to finish the garbage collection, but by that time your old generation gets filled out completely. So your CMS failed to do garbage collection, and your old generation is filled up with the objects. Okay, this particular event you call it as a concurrent mode failure. So CMS is failed to finish its job, and your old generation is getting filled so quickly, so CMS is not able to perform garbage collection. Now that event you call it as a concurrent mode failure. If this particular error, if you start seeing this error in your GC logs, what happens is it initiates a full GC now. Now what it does is it stops everything, entire application threads, and it does the garbage collection on entire heap if that concurrent mode failure happens. Okay, if that event occurs. Now this is bad, completely bad. Full GCs are completely bad, and you never know how long it will take to finish the full GC, right? Very bad. All are happening because of the premature promotions, right? You're like letting object to get promoted so quickly. Now you might see one more error, which is promotion failure. Now what is promotion failure meaning? Obviously, it your younger generation object, the object which is in younger generation, it is trying to promote it to the old generation, but it is failing because of no space inside the old generation. If you are in that situation, you will see promotion failed error. And if you are seeing concurrent mode failure, we discussed already, it means the JVM thinks that current location won't finish before the heap becomes full, right? So why all these things are happening? How can I reduce it, right? First thing first, having good eden space will let the object to stay there, right, instead of getting promoted if you have enough eden space. So the idea is, the ultimate idea is like, you should avoid promoting the object. How can I do that? Having good amount of eden space, instead of having 25% of your heap as a eden for your younger generation, keep like 25 to 40%. Now let's take one example. Let's say, let's go with the 12 GB for your heap. Okay, so that will be overall heap size. So with the CMS you can go maximum 14 GB also, which is good. Anything more than 14 GB is not recommended for your CMS. Okay, the heap settings. Now if you go with 40% for your younger generation, that would be 6 GB out of 12. Now and I'm going with instead of going with 1:8 ratio, I'm going with 1:4 ratio. So with that way, I can get a decent size for my survivor also. So I got like 1.5 GB, 1.5 GB for my survivors, and 3 GB for my Eden space, right? So how it happened, because using form, instead of using 25% heap, I'm using 40% of heap allocated to my younger generation. This way I got 3 GB here, and 1.5 GB for my survivors, and I got like a 6 GB for my Eden space. Now, whenever objects are getting created, you have 3 GB Eden space. You have a large room for your objects to come in. Remember the very first point: objects. Most of your majority of objects will stay very short time. Meaning, you given enough room, enough time for object to die inside the Eden itself, isn't it? By having large Eden room. So by the time Eden gets filled up, whenever GC starts doing garbage collection, it results like, the result would be very few number of live objects, isn't it? So they get promoted, and your survivor is having enough space, so it can accommodate all these objects, right? And those objects will get promoted between survivor 1 and survivor 2 whenever it reaches the threshold. So make sure you keep a threshold value to like more than 5 or 6 or 7, right, instead of the default value 1, right? So that way you are again giving a chance to object to die inside the survivor, right, instead of getting promoted to your Eden. So if you have a tenure threshold set to 5, meaning you're observing the object, if it can die, before 5 minor GCs, or if it stays for more than 5 minor GCs, then you promote it. Otherwise, you let that object die inside the survivor itself. If it get promoted from Eden to survivor 1. Okay. So the overall idea is like, stop doing this costly promotions, and let the object die inside the younger generation. So that is the ultimate point I wanted to convey. So you have to tune accordingly, right? Yeah. So probably survivor ratio 8 will be having higher, lower survivor space. 4 would be give you a decent survivor space, and 10 your threshold set to 5. It's again depends on how what you want, what you're doing at your Cassandra, isn't it? So it depends on the allocation rate, how you define your Cassandra, what are the operations you're doing. So you need to understand the whole piece together to tune them, and never settle down. So you went with some kind of settings, and you got a decent output, and so that is not the end of the world, right? Again, problems may rise. Maybe your approach might got changed at Cassandra level, so you're doing new operations, you bought like a new compaction strategies, right? You're deleting data, or whatever that stuff going on. So we need to understand, how your objects are getting allocated, what is the rate, how many objects you are promoting, like how many objects you are allocating per second. All you need to consider to tune your CMS settings, right? Now, so that is what some suggestions, right? If you rewind everything, one good practice is keeping XMS and XMS to same value, and keeping your younger generation 25 to 50% instead of like going with the default value, so that you can give more space to your Eden and survivor 2. That way you can let object to die inside the younger generation, so that you can avoid costly promotions, right? Now, if you don't want to do this guessing kind of a work, right, and your heap requirements are like more than 4 GB, Cassandra lets you to go with one more garbage collector called G1GC. Okay. So initially when 3.0 got released, G1GC was the default garbage collector for Cassandra, but it backfired completely. So because G1GC will not work with the lower heap on the lower heap on the lower heap basically. So they reverted back and they made CMS as a garbage collector, default garbage collector again. Okay, but the idea is like if you have a longer heap requirement, and you can always have other options like G1GC. So if you want to start using G1GC, the good practice is like disable this particular, comment all your CMS settings and uncomment this parameter and define the pause time, how much pause time you want to keep for your G1GC to finish the garbage collection. So that would be a starting point because the major focus for this particular topic is on CMS. So I'm not going in detail into the G1GC settings, but we'll try to understand how G1GC also works. Now, G1GC also generational garbage collector, meaning like again your heap will get divided into old generation, young generation, survivors, all that stuff. Okay. Now the overall concept is same. The whole piece is same, but the only difference is instead of having one single portion, it divides your heap into multiple um, hidden regions, old regions, and small regions, survivor regions, right? That is how it works. Garbage collector. So it was new in Java 6, officially supported from Java 7 update 4. Okay, so it works very well on a multiprocessor machines. So you can at least skip that whole guessing work when you use G1GC. So that's what your heap will get divided into approximately 2000 regions and everything between like a 1 to 38 2 MB, and all will be of a same size. Okay. So even if your heap requirement is like between 8 to 14, and a properly tuned CMS will be more powerful than your G1GC. So that is the point you have to consider, right? Now there are more advanced garbage collectors are coming into the market. JGC, uh, it is from Oracle, and the overall idea, like the overall idea is to reduce the pass time. All these garbage collectors, right? New garbage collectors, they the main focus is to reduce the GC pause, right? Now, so your JGC is only now currently supportive on only Linux platforms. These are like experimental stage only. That one more thing is like a Shenandoah SGC, which is from Red Hat. So your JGC is from Oracle, and this Shenandoah is from Red Hat. Now, still experimental again. So if you want to try it out, you can find the links. So you can try test it them uh, on your Cassandra. But as of now, the main focus is like G1GC, or like G1GC. Even the G1GC is developed for a long solution for your CMS settings. Okay, for your CMS collector. So there are various garbage collectors, and you can test them out, and you can see how they work. If it suits well, you can start investing time on them and understand it, right? So that's it. Like we came into the climax. So final thoughts would be right. See, all these are happening because objects are getting generated, isn't it? So objects are once the object is generated, then it goes to multiple phases, right? All that stuff is happening. Now, one good point, right? When you want to tune your garbage collection settings, you must start from object creation. Like what is your object creation rate? So you need to see whether you're using the right compaction strategy, right? And you should see tombstones. like if you're deleting lots of data, you're updating lots of data, probably Cassandra might not be a right choice, isn't it? So Cassandra is designed for heavy writes, moderate reading, less updates, less deletes. But you are deleting lots of data, you're updating lots of data, probably you need to think about some other databases instead of using Cassandra, right? And you need to pay attention to your partitions, right? Data modeling, that comes to your data modeling. The recommended one is like 100 MB, but less than 100 MB. But in modern versions of Cassandra, you can have maximum of 400 MB for your wide partition. But still, uh, you have to do careful considerations uh, when you're defining your partition keys, and you need to observe how how what is the growth of your partition, all that stuff. Okay. Now JDK 8, for JDK 8 and CMS, these are two interesting things. Now your CMS is getting deprecated from Java 9. So you are using JDK 8, you can use CMS, but eventually CMS will be will going away. So probably this is the right time to understand G1GC settings and start using G1GC, because G1GC is developed keeping in mind as a long-term solution for your garbage collection. That would be the replacement. And okay, one interesting point, because Cassandra Purvo is coming in, and there will be some different settings now. In Cassandra Purvo, you have multiple JVM files. If you notice, let me put this way, JV, yeah. So because Cassandra Purvo intended to run on either JDK 11 or JDK 8, so you get to see two kinds of files. See, irrespective of whatever the JVM you are using, you can use JVM server options file. But if you are using JDK 8, you have JVM 8 server dot options file. If you are using JDK 11, you can do configuration in JVM 11 server dot options file. Okay, so there are some changes. Okay, so that's it. If you are still here listening to all this stuff, a big thank you. And if you like the video, please subscribe and like it, so that, and if you have any suggestions or doubts, or if you want me to do any G1GC, you want me to go more deeper into the G1GC settings, please comment so that I can do my next video. So please subscribe for more Cassandra videos. I'll be doing more Cassandra videos in terms of administration. Yeah, thank you so much.